Hello, students. We're here in the laboratory today for our periodic table lab. And for this lab today, it is called the Flame Test Lab. And as the name implies, we're going to be using a flame. So I have the Bunsen burner set up before me. I've got my safety goggles on. I've got all of the safety equipment provided in the classroom, and we're all ready for this flame test lab. So the first thing I'm going to do is, light up the Bunsen burner. So I'm going through all of the steps here as we discussed earlier in the year. Good idea for you to be reviewing the steps on lighting the Bunsen burner as well. And so now, turning the system on, and I now have the Bunsen burner lit. Now, I'm going to move to the side here because I think you can see the colors a lot better if you don't have the white background of my lab jacket. So I am going to be sitting off to the side here. Hopefully you can see the flame. And right now we are witnessing a bad flame. Why? Because it's bright and yellow. So we're going to adjust the air intake. And now we've got a roaring, can you hear it? It's a roaring, hot, good flame. Nice, light, and blue. So, as you know from the procedures of this lab, we're going to be introducing 6 different chemicals into the flame. And we're going to be observing the color of the flame and then trying to compare it with an unknown. We're going to identify an unknown substance based on the color of the flame. So let's begin here. Presumably you have already read the problem, written your hypothesis, and now we're ready to make our observations. So our first observation will be of barium chloride. You should be noting these observations in your book in the appropriate location. So let's check out the flame color for barium chloride. And we're introducing the barium chloride right into the top of the light blue flame within the larger Bunsen burner flame. And it's the initial color that we are most interested in. So here is barium chloride. Did you see that? Kind of an olive orange color. Kind of an olive orange color. After it burns away, we will just see the color of the nichrome wire, which I'm showing you now, which is just orange. That's not the color we're interested in. It was the initial color. It was kind of an olive orange for barium chloride. And I know the camera may not do it justice on the video, so that's why I'm telling you the color that I see as well. Our next chloride is calcium chloride. So this is calcium chloride. Let's find out what color calcium chloride produces. Woo! Did you see that? That was kind of a bright orange for calcium chloride. So be sure to write that down. Calcium chloride, bright orange. Our next one is cobalt chloride. Cobalt chloride, let's check it out. Whoa, did you see those sparkles? Very cool. Kind of a sparkly yellow. Sparkly yellow. A little bit left there. So a sparkly yellow for cobalt chloride. All right, moving down to the next one here. We have cupric chloride. Cupric chloride has copper in it. And this is one of my 2 favorites. I saved the last 2 to last because I love these last 2. All right, here's copper chloride. Ready? Woo! Did you see that green? That was an awesome green flame coming out of there. Woo! Kind of a greenish blue. I love that one. That is really cool. That is really cool. All right, our next one is, oh, I forgot this one. This one is potassium chloride. So here is potassium chloride. A little bit boring. That's kind of like a purplish color. Kind of a purplish color for potassium chloride. And that brings us to our sixth and final one. Our sixth and final one, if I can grab it without spilling it here. This one is strontium chloride. Here is strontium chloride. Woo! Did you see that? Red. Very cool. Woo! Okay, so red. Strontium chloride was a red colored flame. And that leaves us with the unknown. I want you to take a moment to look at what you've written down with these different colored flames. And I'm now going to give you an unknown. You are to match it up with your observations from the previous chemicals and see if you can identify this unknown. I'm not going to tell you what it is. You are going to figure it out based on your observations. So are you ready? Watch closely. Here it is. Hopefully you could tell that that was a very red flame. Very red flame. Compare it with your other observations. And you should be able to identify the unknown substance. Now, while I go through the procedures for shutting down our Bunsen burner, I want to talk to you a little bit about why we see those different colors. Why do we see those different colors when we are putting them into the flame? Well, it has to do with the electron configuration of the atom. More specifically, it has to do with the valence electrons. Remember what valence electrons are, right? Those electrons in the outermost energy level. Here's the deal. The color is determined by the number of valence electrons. You see, when you put an element into a flame, you are heating it up. You are exciting it from a kinetic energy perspective. And as a result, you are causing something to happen to the valence electrons. They get excited. They jump up to the next energy level, and then they run out of energy and fall back down. And in that process of jumping up and jumping down, they release energy. And the energy is released in the form of visible light energy that we can detect with our eyes. So it's the valence electrons that are responsible for that color change. In fact, if you examine a number of elements from the same family of elements, you will undoubtedly see similarities between the color flame and the number of valence electrons. Remember, valence electrons are the key to chemistry this year. So I hope you were able to make your observations today with the Flame Test Lab. Finish up your observations, write your conclusion, and then start working on the next item on your list. So until next time, bye-bye.